So I made some mistakes the first time I was trying this, so I reshot it. So I'm reshooting it now, but I already had this, so I'm just going to leave it here. We're going to be looking at the sum and product of the roots. Alright, so the sum and the product of the roots. And that means if we factor and solve for the roots, in this case we get 3 and negative 6. Alright, so the sum of the roots, that's 3 plus minus 6 is negative 3. And the product of the roots, 3 times negative 6 is negative 18. We can find a pattern using the standard form of a quadratic equation. I had written them here. They should really be lowercase, which is why I'm erasing them now. That is, it's going to be the opposite of b over a, so negative b over a. In this case, that's negative 6 divided by 2, which is negative 3. And the product of the roots is determined by taking c and dividing that by a. So that's c over a. And I don't expect you to take my word for it, and this is actually where I made my mistakes before, so I'm going to be a bit more careful. So if we take the standard form of a general quadratic equation, the roots of that will be equal to one of the roots will be negative b plus the square root of b squared minus 4ac over 2a, and the other one will be, which we're going to add to it to find the sum, negative b minus the square root of b squared minus 4ac, also over 2a. So the denominator of this result is going to be 2a. So we have negative b plus negative b, which is negative 2b. And if we add this, if we add it to its opposite, we get 0. So that leaves us with negative 2b over 2a, which is negative b over a. So the sum of the roots of any quadratic equation will be negative b over a. Alright, so you could write that down. Sum of the roots is equal to negative b over a. Now the less fun proof of why the product of the roots is equal to c over a. Alright, so we're going to multiply these instead. So the denominator will be equal to 4a. That's much easier to figure out. The numerator is a difference of squares. If you look at this, these are the factors of the difference of squares. The first terms are the same, the second terms are the same, the only difference is the positive and negative here. So multiplying those through, we get b squared minus b squared minus 4ac, which will simplify to be b squared minus b squared plus 4ac. This is where I messed up before. I left out my parentheses. All of that over 4a squared. I'm sorry, that was supposed to be 4a squared, because 2a times 2a is 4a squared. Now, some things are going to cancel out. B squared minus b squared is 0. 4 divided by 4 is 1. And a divided by a squared is 1 over a. So our final result is c over a. So the product of the roots for any quadratic equation will be c over a. So let's take a look at a couple of test questions that get asked on the nature of the roots, and I have 3 of them that come from the New York State Algebra Regents, Algebra 2 Trig Regents. Anyways, let's take a look. First is to write a quadratic equation such that the sum of its roots is 6 and the product of its roots is 27. So we're looking for values of a, b, and c. We need a. Again, this should be lowercase. I have to stop doing that. A, b, and c, such that negative b over a is equal to 6, and c over a is equal to negative 27. Okay? So let's experiment a little. Values at well, we could, what can we do here? That we could set up a system. This is a system of equations, but we don't have enough information. Alright, so two numbers that divide to b, and divide it this way. So if we're looking at this, b over a is smaller than c over a, so that means b should be bigger than c. What could they be? I think we have the freedom to choose, so let's just make a equal to 2. Why not? B will have to be, if a is 2, then b is going to be negative 12. And since a is 2, c will have to be equal to 54, or negative 54. Alright, so this is a lot easier than I thought it would be. I haven't really done these questions in years, so for me it didn't stand out as so simple. So that is 2x squared minus 12x minus 54 equals 0. Alright, so just knowing this, it wasn't that hard to generate an example. Then there are infinite examples we can probably do in this case. Alright, so let's move on. So this is a question in which we're told the product and sum of the roots, and they're in fraction form. So they're pretty much telling us that since that's equal to negative b over a, and that's equal to c over a, that c should be equal to 3, so it's not going to be this example, it's not going to be this example. It is possible that these have been simplified, so we'll keep that in mind. A should be 4, and since b is negative 9, that would mean it should be negative of that value, so it should be this one. Okay. So that's just knowing what the nature of the sum and product of the roots means. And one last example. What is the product of the roots of x squared minus 4x plus k equals 0 if one of the roots is 7? So looking at this, the sum of the roots is equal to negative 4 over 1, or 4. So we know the two roots, the sum of the roots is 4, and one of the roots is 7. So 7 plus x equals 4. That means x is equal to negative 3. So that's our other root. So that's root 2. Root 1 is equal to 7. So 7 times negative 3 would give us the product of the roots. So that's the product of the roots. But the question wasn't what is the product of the roots. Oh, actually it is what is the product of the roots. The product of the roots is negative 21. It could have asked us what is the value of k. If it asked for us for the value of k, that would be different. K is c, so since the product of the roots is negative 21, that's equal to c over a, which in this case, since a is equal to 1, c has to be equal to negative 21. So in this case, that would answer both questions, if they asked what is the value of k. And that pretty much covers the sum and product of the roots.